typically and stuff like that. De Humani Corpus Fabrica, fun fact, was actually bound in human skin because he had a lot of it laying around. So like now, good job, Andreas Vesalius. So going forward as well, you need to understand this little device, right? Now, this little device right there is going to be a massive breakthrough in both the medical sciences and also microbiology. Some of you are like, that looks like a ping pong paddle. Well, it's not. That bad boy right there is none other than Anton von Leeuwenhoek's microscope, right? So what you're going to see also during the scientific revolution is the birth of microbiology, which we know as well later will actually be heavily applied to the medical sciences, right? Now, Anton von Leeuwenhoek is the guy that actually perfected the microscope that we just looked at 2 seconds ago, right? That gold little paddle thing, and this is him actually putting it up to his eyeball. Actually, fun fact, as you can see, it's pretty small. Like, you would think when you look at it that it's going to be a pretty decent size, but it's actually pretty tiny, right? You would look through that little, like, optical area, the lens right there, and the specimen would be actually mounted right behind it. And so what he did, though, Anton von Leeuwenhoek, as a Dutch scientist, he perfected his microscope, and he's going to be the very first person to view protists or protozoa, basically small organisms, and also even bacteria, right? He observed spermatozoa and stuff like that. Now, the other thing that you need to understand, though, is he did this by perfecting his observational techniques. And his most famous example of this is when he actually looked at a slide of pond scum, right? He actually went into a pond near his house, and he got a little bit of water off the pond scum off the top, and he put that on a slide, and he actually looked through it, and he could actually see multiple organisms moving around in that water and in that pond scum that are not visible to the human eye. Now, the next guy that comes along is an English scientist. He's a man by the name of Robert Hooke, who's going to perfect another microscope, which is much more equivalent to the ones of the modern era. And it's sitting right behind him in this picture right here, right? Looks a lot more like a modern microscope you might see in one of the labs, right? That at our school. So now going into it, though, he also is going to use it to observe some microbiological things as well. You know him from your biology textbooks for when he did this, when he observed cork cells, right? Cork cells actually taken either from a wine cork or from the cork bark of an oak tree, and he actually is going to be the very first person to pioneer the ideas of cell theory, right? Because he's going to realize that human or like living things are made up of small different individual units known as cells, right? And so he's going to actually like pioneer that entire concept. But the interesting thing about Robert Hooke, though, as well, is that he drew everything he saw, right? That right there is his microscope using a lighting source, of course, that he's going to create. And he's also going to draw everything he saw. That right there is one of his recordings of a flea that he actually captured and put underneath his microscope, which is really, really cool, right? Now, the guy that comes along, though, and links all the sciences together is probably one of the most important people in the entirety of the scientific revolution. He's a guy that I love to talk about as well. We're talking about none other than this guy, the famous apple hit me in the head man, which that actually never actually happened. Isaac Newton might be one of the most important people of the entire scientific revolution, right? An English scientist who is going to be alive from about 1643 to 1727. Now, why out of all the scientists do I have this guy's years on there of his birth and life? I think it's really, really important as we book in the scientific revolution together, just to understand how many years this thing took up, right? When you really look at the scientific revolution, starting all the way back in 1543 with Nicholas Copernicus publishing De Rev, theorizing the idea of where the Earth sits in the universe, and really kind of ending off with Isaac Newton, who doesn't die until 1727. As you can see, the scientific revolution is almost 200 years long, and it's going on in the background of everything geopolitical that we will talk about during our era of absolutism, right? So keep that in the back of your mind that the scientific revolution is actually happening during that era of absolutism and constitutionalism, right? Now, Isaac Newton is going to be extremely important for a lot of different reasons, right? Famously, of course, he is going to be the guy that secondhand Fig Newtons are named after, right? Because Newton, Massachusetts is actually named after Isaac Newton, right? But of course, they are then going to invent the cookies called Fig Newtons in Newton, Massachusetts, and that's going to be why they're kind of like not named after Isaac Newton, but they kind of are at the exact same time. So going into it, though, also that we need to understand, he is a physicist and a polymath, right? He is going to be the guy that kind of uses mathematics and physics to link all the scientific branches together, circling back around all the way back to our universe stuff, so we can understand how the Earth goes around the sun and what force keeps it locked into place, right? Well, the big thing that we need to understand about like Isaac Newton's early life is he actually was super pious and weirdly into alchemy, right? Now, the really, really quick thing what I mean by that is he was very religious, right? He was extremely religious and he was obsessed with a lot of really different little things like in his early days, right? He was really obsessed with figuring out two things: alchemy, which is of course like how to like turn random elements into other random elements, which he learned later in life isn't possible. And then of course he was trying to always obsessed with figuring out the day the world would end, right? Now, he got pretty close to figuring out when the world would end, he thought anyway, when in 1665 and in 1666, two terrible tragedies are going to strike London, right? And what's going to happen in London is one, the Great Plague of London, when an outbreak of the Black Death plague will actually pop up in the 1660s. And then another one that's going to happen is known as the Great Fire of London, when over a third of London would be burned to the ground because of a fire that started in a bakery on Pudding Lane. So now going into it, what we also need to understand though is why are those two events important? Well, the thing about it is he's going to run away from London and he's going to abandon some of his work on pious ideas and alchemaic sciences, and he's going to end up in the countryside where his family had an estate. Now, while he was actually on that estate, while he was avoiding dying from the plague and then also from the great fires that were sweeping all over London, he begins to use his observational sciences and he begins to kind of actually do work on something he had been really curious about for a long time: the forces of gravity and calculus, right? Now, apparently, he then, while he was not in exile, but like actually in hiding in the countryside of London, he comes up with the concept of gravity. Now, this, of course, is the origin of the story where apparently he was sitting under a tree and an apple fell and hit him in the head. That actually didn't happen. He made up the story about the apple so he could explain the concept of gravity to people that didn't know what it was, right? And inadvertently, to develop the concept of gravity, he had actually prove it mathematically, he had to develop a new form of mathematics known as calculus. And he records all of his ideas on the law of universal gravitation, and on his ideas of calculus in his most famous book known as the Principia de Mathematica, right? And he publishes that in 1687, catapulting him into fame, right? Now, later on, though, he's going to expand his works into physics, energy, and he's even going to create some theories on optical light after he becomes the president of the Royal Society, right? And the Royal Society, of course, is this group of scientists in England who do nothing all day but study science and try to figure things out. And that's why in the 1700s, he published this idea. He's also the guy that figured out and realized that white light is actually a combination of all the different colors of light. He used a prism to split and separate light using what's known as a camera obscura that had been developed hundreds of years before, right? And he used this prism to realize that all light is, of course, or white light is the combination of all light, and the light that we actually see is light reflected back into our eyes, right? So this genius is going to be the guy that comes along and really perfects the entire scientific study of the scientific revolution. But that is it right there. Y'all go finish up that little Google form after you watch this, and of course, B period, y'all got that other flip that you need to take care of going into our next class, right? But I'll see y'all then. Y'all